let's get started. Please let me know if you have any issue with the sound. And as always, you have the Q&A and the question feature. Seb, what is the main motivation for teaching us? What is my main motivation? What is the motivation of the people supporting me? My main motivation is that when I discovered ICP, I just felt I wanted to share it with other people, because it's like finding a gem or a diamond, and that it's going to be the future. And there was not too much people at that time. I mean, the community was really small. I just wanted the community to grow and get more people involved. My vision for this bootcamp is to create a place where people can build together, because I believe that Web3, we need to build together. It's not like the incentives are different, and there needs to be a place where we can collaborate. I believe a lot in open source and collaborative building, whatever it means. I just feel good when I see people building around me, and I feel good when I teach people and help people. So that's my motivation. And then so I work for Code and State. Unfortunately, if I was not working for Code and State, I don't think I would be able to do the bootcamp for free, because it's a lot of time and investment. Let me put my camera on. But essentially, Code and State is a venture studio that creates venture on ICP, so businesses on ICP. And they are looking for entrepreneurs. They are also looking to expand the ICP ecosystem, because we are 100% focused on ICP. So the bootcamp is part of the strategy. And yeah, the bootcamp connects us with the next generation of builders. Any other question? I'm happy to answer. But yeah, let's do that after this video. Okay. Have a good video, guys, and see you in a few minutes. Goodbye. Hello, everyone, and welcome to this session called Introduction to Building with Motoko. My name is Sebastian. I am education lead at Code and State, a venture studio building on the internet computer. In this video, I will introduce you to the Motoko programming language. It's a new language that you can use to build decentralized application on the internet computer. Why should you learn Motoko? Whether you want to build a game, a social media application, a DeFi application, a messaging application, or you just want to build an application, you can do it with Motoko. With Motoko, you can build almost any application that you want on the internet computer. And if you are interested by Motoko after this video, you can also join Motoko Bootcamp, which is a one-week program that I run every month, where I teach you how to build a DAO on the internet computer. You will join other builders and you will learn and build together. If you're interested, check out www.motokobootcamp.com. The internet computer is a decentralized cloud. You can think of it as a mix between a cloud and a blockchain. The cloud is necessary for running application, and the blockchain part is necessary for the decentralization of this cloud. On the internet computer, you can build decentralized application, also called dApps. Decentralized applications are applications that are owned by communities and users instead of owned by big corporations such as Facebook, Google, or Amazon. Why does the internet computer matter? Well, on the internet computer, you can create applications called dApps and put those applications under the control of a DAO. A DAO is a decentralized autonomous organization, which is also an application running in a fully transparent and decentralized manner. Once you have a DAO, you can have investors, users, and developers collaborating together for the application without having a company that controls the application, which means that we can now collectively own and control software, which is a game changer, and this is what I talk about and teach in the Motoko Bootcamp. If you want to know more about how the internet computer works, I have created a dedicated playlist called Understanding the Internet Computer, where I dive into the technology that makes the internet computer possible, the consensus and the protocol, and the cryptography behind the technology. As I've said previously, on the internet computer, you can build any kind of application. You could build a messaging application like OpenChat. You could build a social network application like Discover. You could build a decentralized finance application like ICP Swap, or you could build a game like Dragons. All those applications are built using what's called as a canister. A canister, as you can see here, is a mix between the code for your application and the state of your application. The code of your application is a WebAssembly module, and the state of your application corresponds to the WebAssembly WebAssembly memory. On the Internet Computer dashboard, which is an important dashboard that captures and collects all metrics related to the Internet Computer network, we can see the number of canisters deployed on the network. Currently, as I'm recording this video, we are January 2024, and there are 377 and 381 canisters deployed on the Internet Computer. If you are familiar with Ethereum and other blockchains, you can compare canisters to smart contracts. If you are familiar with Docker, you can think of canisters as containers. And if you are familiar with none of the previous environments, you can think of canister as a mini computer that stores all the code, all the variables, functions, assets necessary for your application. For this video, I'll make a prediction. I believe that eventually everyone is going to have their own canister containing their own data. Canisters combine the properties of smart contracts, the properties of containers, and the properties of computers. Before we write our first lines of Motoko, I would like to show you how things work when you interact with an application deployed on the Internet Computer. The application that I'm using today is called OpenChat. OpenChat is a messaging application fully built on the Internet Computer. It's actually the first application that was controlled by a DAO. And I'm also using something called IC Inspector, which is a Chrome extension that you can use, and it will monitor all interaction between your browser and the Internet Computer. We have this Motoko Bootcamp group, and I'm going to send a message and show you the interaction that happens between my browser and the Internet Computer. For that, I will inspect the web page and open the IC Inspector. So the IC Inspector is on, as you can see here, and it's recording every interaction. As you can see, we have a few interactions going on already. Now, notice what happens when I send a message. As you can see, this new function has been sent called send message. It's update, and there is a canister ID here, which is actually the canister ID that I'm communicating with. So every interaction with the Internet Computer is actually a call to a canister. So as we've seen, any application built on the Internet Computer runs inside a canister. Every interaction that you have with the network is a message that is sent to a canister. An interaction can be posting a message on social media, transferring a token to a friend, or even just reading your messages on a messaging application. All those messages are processed by the canister, and an answer is returned to you. All right, let's deep dive into exactly what a canister is. Don't worry, we'll explain every single part of this picture. When I started and discovered the Internet Computer, it took me several weeks to understand what a canister was. Don't worry, I'll make it short for you and explain in 5 minutes everything you need to know about what a canister is. Okay, so we've said that a canister is divided into two parts. The first part is the WebAssembly module. The second part is the WebAssembly memory. The WebAssembly module corresponds to the code of the canister. This code comes from the code written by developer in language such as Motoko, Rust, TypeScript, or even other programming languages that compiles to WebAssembly. Once developers have written their code, the compiler of the specific language or other related tooling will compile this code to a WebAssembly module. Then this WebAssembly module is installed inside the canister. If you want to upgrade a canister, you need to change the WebAssembly module. The WebAssembly memory contains the state of the application. Anything like token balances, user profiles, NFT, files, assets stored in the canister are stored in the WebAssembly memory. The WebAssembly memory can be modified through the WebAssembly module. The code can affect the memory. Canisters require cycles. Cycles are like credits. Cycles are used to pay for computation and storage cost of canister. Each canister has a cycle balance. Usually, developers will pay and charge their canisters with cycles. If a canister runs out of cycle, it can be deleted by the Internet Computer. Note that also users and other canisters are able to send cycles to other canisters. Okay, let's move to the user side. We can interact with canisters only through public functions. It's important to understand that the memory of a canister is not exposed by default. Otherwise, anyone would be able to see messages and interactions happening on the Internet Computer. A canister can only be accessed through these public functions. Developers will specify public functions when writing their code, and those public functions can be used either to execute the WebAssembly code or to look into the WebAssembly memory. For example, post message would be a public function, read message would also be a public function. Those public functions can be called from different places. Actually, any canister on the Internet Computer can call other public functions of other canisters through intercanister call. Also, developers can use something called defix, which is a command line tool that we will use during Motoko Bootcamp, can be used to call any public function of any canister on the Internet Computer. The candid UI is a specific interface that is generated automatically and contains a list of all the public functions of a canister. This candid UI can also be used to call those public functions. Finally, and that's how most users will interact with canisters, a frontend can be used to call public functions. For instance, when I was using OpenChat, the frontend was loaded in my browser, and when I sent my message, the frontend sent a request to the canister. Public functions will execute specific code in the WebAssembly module, and this code can change the memory or read the memory. Applications built on the internet computer can use one canister or multiple canisters for different purposes. For example, an application could have a canister for the backend and a canister for the frontend. Now, and especially if you're starting your developer journey, you might be wondering, but what is exactly WebAssembly? We keep talking about this WebAssembly module, but what is WebAssembly? WebAssembly is a virtual machine for the web. It enables developers to write applications in multiple languages such as Motoko, Rust, TypeScript, Java, and have it compiled in WebAssembly. WebAssembly runs on almost all possible devices: browser, server, computer, IoT devices, and on the cloud. WebAssembly compiles to a binary format, which is both efficient and extremely fast. Yes, WebAssembly is an amazing technology, and it's a huge component of the technologies that makes the IC possible. If you want to know more, I will put some links in the description, and I also have a dedicated video for WebAssembly if you want to dive more. So, if WebAssembly is so amazing, why don't we write our canister code directly in WebAssembly? Well, in theory, you could use WebAssembly. This is an example of a counter that was written in WebAssembly. Counter.what? What means WebAssembly textual format. There is a textual format that is actually converted to the binary formats I mentioned. And this example comes from the definity/example repository, which is a repository containing many examples for the internet computer, for Motoko, Rust, and even WebAssembly. This is actually the only example that is written in WebAssembly. This is because, as you can see, this is only an application that stores a counter, increment a counter, and where you can read the counter. And it takes around 106 lines to write this in WebAssembly, and also the code is really hard to read because WebAssembly is a low-level language close to binary or assembly, and so that's why a developer needs an abstraction to work on top of it. There was no language dedicated to WebAssembly and the internet computer, and that's why Definity, the foundation behind the internet computer, decided to create Motoko. Motoko is the first language and the only language dedicated for the internet computer. If you're excited about ICP, you need to learn Motoko. 2 years ago, I decided to learn Motoko, and it was one of the best decisions that I ever taken in my life. Oh, in case you're wondering where the name Motoko comes from, I'll let you have a look at the Ghost in the Shell wiki /Motoko Kusanagi page. Okay, let's start to write our code and start to build our application. I would like to introduce you to the Motoko Playground. The Motoko Playground is an online coding environment for Motoko that we can use to deploy canisters completely for free and without having to set up anything on our machine. We will deploy in a special part of the internet computer called the Playground. On the internet computer, if you want to deploy applications, as I said, you need to buy and pay for cycles. On the Playground, we can deploy for free. The Playground has some limitations. Any canister will be deleted after 20 minutes, and also we cannot deploy cycles. We cannot send cycles to other canisters, and you can probably imagine why. Okay, so the first thing is to click on New Motoko Project, and it will open a main.mo file, main.motoko, and a blank editor. Okay, so let's take a look at the application you will build today. The Candid UI is a visual interface that enables us to access the public interface of the canister. Of course, I have already deployed this canister, that's why we have access to the Candid UI. So the canister that we want to build today has a simple function. The function is to store a message, and we have one public function that enables us to see the message that is stored, and one function that enables us to change the message. As you can see, the changes are reflected. Also, there is another function which essentially returns the number of times the message has been changed. So in our case, just one. Let's start with a very important rule. Any canister written in Motoko always starts with the keyword actor and brackets. The entire code that you are going to write, all the functions, all the variables, will fit inside the two brackets. Why actor? This is because a canister is abstracted as an actor in Motoko. Actor comes from the actor model. Here is a simple animation that explains the actor model applied to canisters. Imagine that you have two canisters, canister A and canister B. Canister A stores a counter. Canister B wants to access the value of the counter. Unfortunately, canister B cannot directly read the state of canister A. And that's why canister B will have to send a message to canister A. One thing that can happen is that canister A receive another message, because actor can send messages to other actor. Canister A will treat the first message, increment the counter, and then treat the second message, get counter, and return the value of the counter to canister B. We need to define three variables. We need a variable to store the message, we also need a variable to count the message, and we need a variable default message. The default message will be used in case message is empty, so we can notify our users. Before we define our variables, we need to understand that Motoko is a typed language. This is an extremely important part of the language, and this is what makes Motoko a safe language. So let's say I define a variable called n, and I assign it a type NAT and a value 0. So in case you're wondering, this is the type assignment operator, and this is the type I assign this variable. NAT stands for natural numbers, which are all the numbers from 0, 1, 2, up until infinity. Once I have specified n as a NAT, I can never use n for operations that require another type, like a text or a boolean. There are many types in Motoko, but for today we will only care about two types, which is the type NAT, as we've seen, and the type text, which enables us to store textual messages. The first variable that we want to define is the message. We need to use the keyword var, because in Motoko, variable defined with var are mutables. But variable defined with let, as I've done previously, are not mutable, they are immutable. Immutable means that you can never change the variable. In the case of the message, we want to be able to change it, so we use var. We can specify the type of type text, and we can set an initial value for the message. At the end of any variable declaration in Motoko, you need to add a semicolon. And that's our first variable. We can add a comment with 2/, store the message, mutable variable. The second variable that we need to define is the counter for the messages. Count the number of messages. It also needs to be a mutable variable. In this case, it needs to be a counter of type NAT, and we can initialize it to 0. Again, don't forget the semicolon at the end of every variable declaration. The final variable that we need is the default message. The default message is an immutable variable. A default message in case the message is empty. Immutable variables are defined with let in Motoko. The value of this variable can never be changed. Now we do functions. Oops, I'm not sure what's exactly happening here. Let me see. I have an issue with the recording, obviously. So this part, this part I can actually maybe show you by myself. So let's see. So in the recording, we were implementing that. That's our first function. Okay, so this is just about the function change message. So we have a message of type text, which is hello world. We have a counter of type NAT, natural number. So natural number are 0, 1, 2, 3, and so on. And default message which is also of type text. The message is empty. Okay. Now, what is missing in the video is the part about changing the message. So public function change message. This is how you define a function. Public means that this function will be accessible from outside of the actor. So this is our canister, and this function will be accessible outside of the canister, which means a user can call this function or another canister can call this function. We will see later that we also have what's called as private function that cannot be called from outside. But right now we are only working with the public one. Then func for function, this is just a shortcut, and then the name of the function, so change message, and then the arguments. So we will have one argument, which is the value of the new message, and we also need to specify the type of this argument. Then we need to specify the return type. So a function takes some arguments, process whatever code it has to process, and then return something. And in that case, we want to return nothing. We just want to change the value of the message. So if you don't want to return anything, you can use this unit type, which is what is specified here. And it's essentially meaning that you return nothing. Async comes from asynchronous because every public function of a canister is asynchronous by default. And you need this async every time you define a public function. Why? This is because of the actor model, as I've explained in the little animation. Asynchronous means that whenever someone is calling this function, so if it's a user or another canister, this person will have to wait to receive an answer. Because you cannot know, maybe you're sending a request to a canister and this canister is already working on other stuff, working on other requests, and it cannot answer you immediately. So this is why we have this concept of asynchronous. And then, so we can change message. We can allocate the value of message to a new message. So this is how you would do it. And then just return. And that's already good. Now we can get back to the video because I think that's only this part that was corrupted. So let me see. We were here.
We will leave the return.
Yeah.
Finally, we can return.
Okay.
Note that in Motoko, we could forget to put the return. And this would still work because Motoko automatically returns after the last instruction has been executed.
Oh yes, sorry guys, I actually forgot here to increment the counter because we want to have this counter that counts the number of times we have modified our message. So I forgot this here.
Just for clarity, we will leave the return. Note that we don't return anything, and that's why we have this unit type. That's our first function. Our second function will be a query function. And for that, I need to explain the difference between query and update. The first function that we wrote, change message, is an update function. An update function goes through consensus. This is because this function actually changed the states of the canister. As you can see, we changed the value of the message and we also changed the value of the counter. The next function that we'll write is a query function. A query function can be used when you only want to look at the states, but you don't want to commit any modification. A query function does not go through consensus and can be answered by a single node. This is why a query function is also very fast. Okay, so we want to create a function that returns the message. This is a query function, and it does not go through consensus. This one takes around 200 milliseconds. This one takes around 2 seconds. To define a query function, we need to add the query keyword between public and func. This function will not take any argument, so we can leave empty, but it will return a text corresponding to the message. And we can simply return the variable message, and that's it. The last function that we want to create is a function that returns the value of the counter. This is a query function that doesn't use consensus. Oops. We also use the same syntax, public query func, c counter. We take no arguments, but this time we return a natural number instead of a text. And we can simply return the value of counter. One thing I forgot in this function is to actually test if the message is not empty. So if the message is empty, and this is how I can check, message.size is returning the number of characters in the message. If the message.size is equal to 0, I can return default message. Otherwise, we return the message. And that's it. We are ready to deploy. To deploy a canister on the playground, we simply need to click on deploy in the top right corner. After that, you can see those configurations. You can configure the name of the canister, and you can also configure the garbage collector. The garbage collector is useful for Motoko. We can stay with the incremental garbage collector and just click on install. Once your canister has been deployed, you will see a countdown appearing on the left. This countdown represents the number of minutes your canister will remain on the internet computer. Once the countdown is over, approximately 20 minutes, your canister will be automatically deleted. You can also see the canister ID, which is an identifier corresponding to your canister, and you can see the size of the WebAssembly module installed in the canister. On the right, we have the Candid UI. We can access the Candid UI in another tab by clicking here, and we can interact with the public functions of our canister through the Candid UI. I can see the message, see the counter, and change the message. Notice that those are query calls. They perform pretty fast. This is an update call, and it takes more time because it has to go through consensus. Usually, the playground is slightly slower than the internet computer because the playground is a specific part of the internet computer. I can see the counter being updated, and I can see a message here. And that's it. We've deployed our first application using Motoko on the internet computer. All right, so we are at the end of this presentation. Do we have any questions? So I can see already a few questions in the chat that I will take. Okay, I can see a few questions. So public function can be accessed by anyone, but what if 10 different canisters have a function change message, all with different logic? So yeah, when you call a function, of course, you need to know which canister you're calling. And so it's not going to be a problem if everyone has a different function. I mean, if you're calling a canister, it means that you trust it, or that you have been developing it, or that you have access to the code to somehow. So it depends on what you're building, but yeah, it can be a problem in some circumstances. It cannot be a problem in others. I'm not sure I got if they all have a different logic, then it's it depends. It depends. Is let similar to const in other languages like JavaScript? No, because in JavaScript, you can change a let, so you can change the variable. In that case, when you have a let, it's what is called as an immutable variable. An immutable variable can never be changed. So you can never change this value. It's just a placeholder for any kind of value that you want. but you cannot change the value of this. If you want to change it, you need to create a new variable. So var would be like a let, and let would be like a const in JavaScript. What is being built exactly? Yeah, maybe I should have explained a little more, but we just wanted to build a simple application that stores a message, text, and you can change the message, see the message, and also there is a counter that counts how many times the message has been sent. So that's one of the simplest application we could build. Do we have to write the what file? So the what file is the WebAssembly textual file, and we don't have to write it. We don't have to write any WebAssembly, never. Even the binary or the textual representation, we never have to write WebAssembly. WebAssembly is compiled from the Motoko code that we write. So this is not something that we have to care. I'm just showing you that there is this WebAssembly file because I think it's important for you to understand that Motoko is the language that you use, but not the language that is running on the IC. But you don't have to write it, of course. How do you access Motoko Playground? I can see the link. Yeah, the link has been sent. Can a canister be exploited or hacked? Yes. So in general, yes. Then it depends on where and how and who is attacking and so on. There are a lot of topics that we could go into regarding security, but generally, so the ICP protocol can be considered safe. Nothing is perfectly safe. Like in general, in software, nothing is 100% safe. It doesn't exist. Of course, Bitcoin can be considered safe because there are billions of dollars that have been stored. And if someone could hack it, it would have already been done for a long time because there are the incentives. And the same thing with ICP. If someone would be able to hack the protocol, there are millions of dollars to get access to. So people would be incentives to try to hack it. Now, even if the protocol is considered safe, then when you write an application and deploy a canister, it's up to you to make sure that your canister is safe. So you can have applications on ICP that are safe. You can have applications on ICP that are not safe. And it depends. So I could easily build an application that is not safe and deploy that. And then it's not because an application is built on ICP that is safe, and it's not because it's built on ICP that is not safe. It's just a balance. In general, I would say that ICP makes security issue easier to deal with because you have the protocol that takes care of a lot of security assumption. So as a developer, it's easier to deal with security than in most cases. No, right now you don't have to do anything. So just to be clear, this was an introduction. So this is not the coding session. We have a coding session later. I just wanted to show you how to build a simple application. In the next session, we will use Gitpod. So we will set up an environment on Gitpod, and we will need to submit an application on the dashboard, but this is not for right now. Can we spoof our ID on a query function? Just like in Ethereum view function. What do you mean spoof? Like the idea of the canister? I will need more explanation on this question. When I have a data model with a person and a project, no. If you have different data, you can create multiple types in Motoko, but you wouldn't create one actor per entity. One actor represents one canister, so it's not something that you you wouldn't easily make multiple actors. You could make multiple actors, so you could make an application that has multiple canisters, but it's something very advanced, and it's not something you would do in many cases. One canister can store up to, I believe now it's 300 gigabytes. So it's way enough to store, like for example, the whole Bootcamp application is just one canister. I know that most applications use only one canister. OpenChat uses multiple canisters, so they use one actor per chat group because they have built their application in a certain way. But in general, you can have a lot of data and a lot of types stored inside one actor. The Motoko playground, we will use it for the mentorship session and generally for short session. But this is not where we will use build and deploy our canisters. We will use something else that we will see this afternoon in Gitpod. The playground is good if you want to quickly deploy something or try out some Motoko code. So it's just easier to do it from here. So someone wants to see the code. I can show you the code, yes. But it doesn't, you don't have to take any screenshot. I mean, this was just to show you an application, an example. But it's not something that we have to necessarily do again. So yeah, I hope that can help you. Yeah, that was the entire code. Oops, 1 second. In the Motoko playground, you can deploy examples. Yeah, so there is a good feature, which is that you can use the playground to access example. If you click on open example, you have a hello world, a counter, calculator, and so on. So you could do like a counter, for example. And you can see how to do a counter in Motoko. So that can be useful if you want to, you know, get more comfortable with the language itself. Can you show us how to write doc strings? I guess you're saying like comments, right? So yeah, you can do it simply by, no. Yes, so documentation would be like comments. For example, you would do like public function greet, let's say name, and you return hello takes an argument of type text and returns a greet message. This would be how you would do some documentation for your function. So this is exactly the same as a comment, at least in Motoko, that's how it works. And we can try this ups and return. It is the official way. So this is the official way to do it. And yeah, I can try that and it should work. So docstring, yeah, docstring is a feature of Python, I guess, and other languages, but we don't have that in Motoko. The extension is called ICP Inspector, but you don't have to install it. I just wanted to show you because I think it's great. If you want to install it, feel free to install it. Essentially, you have this extension, and now every time you use an ICP application, for example, Discover is an ICP application. Every time you use one, you can go here in your, oh, wait, I think I have deactivated. Yeah, it's here. So every time you go here, I need to reload. And you can have information. I still don't have it. Yeah, finally. So I can see all the interaction that take place. As you can see, that's a lot of query function. So probably when you load a website like Discover, there are a lot of query function. Query function, as I've said before, are the functions that do not go through consensus. So essentially, you don't need to have a lot of resource and a lot of nodes that answer a query because it can be answered by a single node. That's why it's super fast and super cheap. And then whenever you want to change the state of the application, so if you want to post a message here, like something, send a token, you will need to use a query function, an update function, my bad. For example, if I try to edit my profile, maybe, I don't know, I try to change that. Let's see. I remove that, updates, and then I guess I should be able to see, but there are a lot of query that goes in the background, so I'm not sure where is my updates. There are too much query going on. I can see anything. Yeah. It only keeps the latest 100 messages. So it's calling every canister, like those are all NFT collection. It's calling all the NFT collections. And this is too much messages for me to show you. No, the normal developer tool will not necessarily show you, like it will show you query like this. So you can see this. But you don't have as much method, as much information as the ICP inspector. So the ICP inspector will show you the name of the method, even some arguments. If there are some arguments, you can even see that. You can see the canister ID that you're calling. You can even see in which subnet this canister is located. So the ICP is divided into subnets. You can see which subnet your canister is located inside, the canister that you're calling, and all sorts of information about the canister. So you can see the payload. And if you have access to the candid interface, so this one you don't have access, it's also going to decode the answer for the request for you. So you will be able to read in a human readable format the request. Should I do my initiation after we are done with today's session? Yes, so I can see that we are on time. We can actually finish this session here. The next session that we have is in 1 hour and a half around, and 15 minutes. We will start to code. So the next session, you will start to code and implement your first project. In the meantime, you can either do your initiation challenge if you haven't done it, or you can start to explore the repository for the bootcamp. So we will use this repository. You can start to have a look. I send the link in the chat. Okay, so that's it for this session. This was a quick introduction to Motoko. Next one, we will code, and take care. Keep building in the meantime, and I see you in 1 hour. Goodbye.